Good morning, everybody, and welcome to math. It is Monday, November 9th, and today we are working on deepening our decimal concepts. Last week we introduced ourselves to the concept of a decimal, taking those place value base 10 patterns and knowledge that we already had coming into fifth grade and merging it with our fractions concepts of taking one whole and breaking it into equal parts. So we're going to deepen that today. Here's what you need, the usuals, something to write on, something to write with, and then down here are our I cans. I can understand that decimals are equal divisions of 1 organized in groups of 10. And I can use place value knowledge to add two numbers that both have decimal values. Let's get right into it, and we're going to start today with an episode of my favorite no. If you remember from past episodes, my favorite no is a great way to think about all of the good math that's happening in an equation or in an inequality where maybe there's one crucial error that is between the mathematician and a perfectly correct, mathematically accurate answer. So here is the answer to one of our problems from our exit ticket last week that I saw from a few different people. 11 and 91 hundredths plus 3 and 65 hundredths equals 14 and 156 thousandths. I saw this exact answer from a few different mathematicians, and I happen to love this answer because I did not expect to see this outcome. I did not expect to see this answer when I initially made this problem, when I initially posed this problem. And I love it when I see something, as a math teacher, I love it when I see some mathematical thinking that even didn't occur to me as something that, as an option or something that we could go. That's part of my own sort of math thinking is, my generation and your parents' generation, the fifth graders watching this, we learned math in really different ways than you're learning math. We learned a lot of that procedural fluency, how to use the standard algorithm over and over and over again and get an accurate outcome, but we didn't think about math as flexibly or as creatively as y'all do, okay? And so an answer like this, for like kind of my old mathematician brain went, wait a minute, what happened here? But then my sort of newer mathematician brain, as I've learned to think about math in different ways in my becoming a teacher, I went, oh, this is some good stuff. So let's first think about what is this mathematician, or what is this no doing really well? Okay, take a look at this problem. See if you can identify some things that this mathematician does really, really well. Okay, one thing I'm noticing, keeping the whole numbers and the decimals separate. I can clearly see here, there's our 11 plus 3 is 14, and I can clearly see our 91 plus 65 equals 156. I would 100% agree with that. That is completely accurate math. I'm noticing this mathematician did whole number plus whole number to get whole number. Decimal plus decimal equals decimal. Okay, really keeping that divide clear between whole numbers and decimals, and using that decimal point as really the divider between whole numbers and decimals. Okay, what else is this mathematician doing really well? Well, using the correct operation, right? We don't see like an 8 here. If they had done 11 minus 3, right? That's our clue that they accurately subtracted, but this problem didn't call for subtraction. But in this case, they're clearly adding, right? They're clearly doing the right operation. So that tells me a lot more about this mathematician. The other thing that I'm really noticing, and this leads me to the shift in thinking to move this from a no to a yes, is I'm noticing here this mathematician has a really strong sense of when there are 10 of something you make a new place to the left, and it goes one place to the left. Because I'm noticing here, right, taking our 5 plus 1 is 6, for sure. 9 plus 6 equals 15. And I see that really, really clearly, right? If we were to do this in whole numbers and do 91 plus 56, or excuse me, plus 65, sorry, 91 plus 65, 1 plus 5 is 6, 9 plus 6 is 15, and you're going to have to create a new place to the left, our hundreds place, in order to make all of that fit. Okay, so I love that the mathematician did this. Here's the shift from my favorite no to a yes, is when we set up our problem in vertical form, 11 and 91 hundredths plus 3 and 65 hundredths. Okay, and we've got our decimal points lined up. Our decimal point in our answer is also going to stay in that same spot. Okay, still going to stay lined up. So our tenths are always going to be here, our hundredths are always going to be here, our ones are going to be here, tens, and so on. Okay, and that is the advantage of vertical form. It keeps everything lined up. So as a mathematician, you're able to be a little bit more accurate and organized. Okay, so 1 plus 5 is 6 in the hundreds. 9 plus 6, we have 15 tenths. And if we were to write that out as a fraction, 15 tenths. Okay. How many tenths would be an equivalent of 1? See the glare there. There it is, 15 tenths. How many tenths would be an equivalent of 1 in 15 tenths? Right? Yeah, we have 10 tenths equals 1 plus, how many more tenths do we have here? 10 plus what is 15? 5. So we have 5 tenths. And this 10 tenths is an equivalent of 1. Rather than create a new place to the left, we already have a place to the left of our tenths place. It's our ones place. We have a 1 here. So we're going to regroup to the ones place and leave our 5 extra tenths here. Okay? And then 1 plus 1 plus 3 is 5. And then 1/10. So we end up with an answer of 15 and 56 hundredths. Okay, do we see how this answer and this answer super close to each other, right? All this mathematician had to do was, rather than create a new place, which they did, because when we add whole numbers, that's absolutely what we do. If we don't have anything to the left, we create a new place. Because in that case, if we had, going back to our 91 plus 65 in whole numbers example, right? There is a place to the left. There's a hundreds place here, but there are 0 hundreds in either of these numbers. So the 100 comes from putting it in a hundreds place where there was nothing there. In this case, right, there is something in the next place to the left. It's just on the other side of the decimal point. Okay, so I really love this thinking. The shift here is when you're adding in the tenths place and you have to regroup, okay, rather than create a new decimal place, know that 10 tenths is the same as 1/1. So you'd regroup over the decimal point into the ones place. All right, really, really great answer and great thinking here on this favorite no. This mathematician really knows their stuff. And again, a few of you did this exact thing. So that tells me that you're really thinking and really comfortable with those place value concepts. Now, the only thing is the decimal point doesn't mean there's like two separate things here. All it means is this is where whole numbers end and decimals begin. So if you create a whole number, goes to the one side. Okay, so this would be our accurate answer here. Okay. What this mathematician did here is instead of 5/10 and 6/100, they ended up with only 1/10 and 5/100 and 6/1000. Okay, so by adding a new place, what you've done is you've essentially taken this 5 in the 10th, which should be in the 10th place, and our 6, and given them 1/10 of their value. Okay, so you do end up with an inaccurate answer that way. All right, so here's our most accurate answer, but this is really good thinking here. Let's go to our whiteboard, our digital whiteboard. Well, kind of our digital blackboard, should we say. And let's try a couple here. So first, let's work on some naming, okay? Because I did notice some misconceptions around the naming of our numbers. So I'm going to draw out, I'll go black and pink here. I'm going to draw out, here's our decimal point, and then here's our tenths place, and here's our hundredths place, okay? And then here's our ones, and here's our tens, and so on, okay? Just like place value, these continue 10 times more, 10 times less. So the important thing to note when you're naming and being able to identify decimals is knowing what place is what place in your number has value. Okay, so if we have something like 5.4, okay, what value would go in the hundredths place then? Yeah, theoretically a 0, which, because there's no other value, there's no thousandths, no 10,000ths, and so on, you don't actually need that 0 to accurately represent this decimal. Okay, it can just be 5 4/10. Just like you don't need a 0 here either, although technically there is one there. Okay, again, all a 0 does is it's a placeholder in our place value. It takes up the space where there isn't value there in case there's value somewhere else. For instance, if it was like 305, you'd need a 0 in the tens place because you've got some hundreds. So for this one, it would be 5, and I always think of when you see the decimal point, you're saying and there, 4/10. Okay? What if our 4 was in the hundredths place? If our 4 was in the hundredths place, this is where we would need a 0 in the tenths place. Because again, it's acting as a placeholder so the 4/100ths can be accurately represented. If there was nothing there, then technically it would be in the tenths place and wouldn't be hundredths. But if we have 4/100ths, you had $5.04, you would need that 0 there, otherwise people might think they're dimes because they're tenths instead of hundredths. Okay? And then the way you would say and write this number is 5 4/100ths, because our value goes all the way to the hundredths place. Okay, when we start to incorporate thousandths, the same will hold true. So this would be 4/1000ths, right? Imagining we took one whole, cut it into 1,000 pieces, and we currently have 4 of those pieces. 4/1000ths. All right, so let's say we had something like this. What would we call this number? would be 5 and 18 hundredths. Okay, rather than just saying 1/10 and 8 hundredths, we're going to group them together. And it really does kind of look like an 18, right? So we're going to say 5 and 18 hundredths because it goes all the way to the hundredths place. If we were to kind of reverse engineer this here, okay, let's say your assignment is to create the number and write the number 11 and 84 hundredths. Okay, so we have 11. We know we have 11. 11 and 84 hundredths. Okay, this one's pretty self-explanatory, right? 11 is our whole number. And our 84, making sure that it ends, or our 84 ends, the rightmost place is in the hundredths place. So 11 and 84 hundredths. Okay, if you had something like 11 and 84 thousandths, it would look quite different because your 84 would have to end in the thousandths place. Like that. And then, oh, we have an empty tenths place in the middle. So what are we going to need to do? We need to put a 0 there. So this would be 11 and 84 thousandths. Okay, so if you have trouble, or if you have a little bit of struggle writing out these numbers, okay, or thinking about these numbers, I would actually go ahead and take the extra step of writing the names of our places below them, okay, remembering that the place just to the right of the decimal point is the tenths place. The place just to the left of the decimal point is the ones. And then actually writing out the names for our places below, because that's going to give you a better idea of what those places are called. Okay? So that was the other sort of misconception I was seeing with the naming. All right, so on your exit ticket, you're going to have two different kind of things to do here. Okay, the first one is around that naming. You're going to get some numbers and asked to numbers in word form. You're going to ask to write them and name them. So write them out and put those places below, just like on the whiteboard here. Okay, and then we're going to do some adding. So remember, with the adding, just like we did back here, write it out in vertical form. Keep the decimal points lined up. And if you need to regroup in the tenths place, you regroup it to the ones, because 10 tenths equals 1. All right, good luck. The math Zoom room will be open in about 10 minutes for support and extra questions. Otherwise, good luck. Finish it up, turn it in, have a good lunch, and we will see you this afternoon for science. Happy math.